Okay. Good afternoon, everyone, and welcome to today's webinar session on the latest trend in wear register coating in industries. I am Hitesh Kumar Dave, Assistant Professor, Mechanical Engineering Department. I would like to introduce today's presenter, Mr. Pravit Pamar. Mr. Pravit Pamar is the Technical Director of both the Ferrous Industries named Mangalam Steel Cast Limited in Vadodara and Sine Engineer Private Limited in Indore. His second generation foundry mainly looking after new product development, improving the technical capabilities, enhancing the qualities, optimizing the process and cost, and improving the working environment in the foundries. He received his education at IIT Varanasi, BHU, and his master degree from Cornell University, USA. Prior to joining the foundry business, he worked as a lead research engineer in Siemens in R&D department, where he published 2 patents. He is an active member of Indian Institute of Foundry Association (IIF), India's largest foundry association, and is currently the Honorable Secretary from the Western region of India. In past, he has served as a chapter chairman and secretary of IIF Vadodara chapter as well. Along with the foundry industry, he has established his own setup to serve the industry with a unique service to supplying hard-faced wear resistant part under the name of Wear Fighter Division. He has partnered with a French company that has a patent for manufacturing exceptionally high hardness coating material that prolong the life of wear parts multiple times. A few details about the same will be seen in his presentation. Working from the last 7 years in wear resistant part, he has gained quite an insight into this industry, and today he will be shared his experience on the same subject. If you have any query or question during the webinar, then you can email to hitesh.dave@paluniversity.ec.in. Also, you can write down the chat box of our Facebook live session. Now, without taking much time, we will turn the time over to Mr. Pravit Pamar. Sir, welcome to you.
Thank you very much. Should I share the screen?
Yes, sir.
Yeah, is it visible?
Yeah. Yes, sir, it is visible.
Okay,
continue.
Great. Thank you very much, sir. Thank you for the introduction, and good afternoon, everyone. I really want to thank you for attending this webinar, which is basically on latest trends in wear resistance coating in industries. So, just a minute, I had this thing. Okay, so basically, it's as such, it's a very vast topic. It has many applications, and if I start getting into it, it will take me a series of lectures to introduce about it. But right now, what I'm going to do, it's just my presentation will brief you about a basic information, what is basically wear resistant material, what type of coatings are there, and currently in industries, what are the normal phenomena that are being used. And secondly, because it's a topic of interest for many, it's the presentation is mainly for the you can say educative purpose. So having a basic know-how, you can see if you have some interest in this area, you can take it forward. So basically, I made it for the students and who are studying in the engineering right now, and they can see this is also one area which has to be focused, and you can take it forward from here. So let's begin with it and try to understand what is, first of all, what is the wear? Wear as such, many of you might be knowing it. It's defined as a progressive damage to a solid surface by the action of relative motion with the contacting system. Basically, it's when we have a rubbing phenomena. Whenever there is a rubbing or a sliding phenomena, there is a friction generation between the two surfaces, and due to that friction, there is a loss of certain material depending on which material is capable to handle the other material. So this rubbing phenomena, due to this rubbing phenomena, there is a surface reduction or you can say it's a loss of the material from the surface. So this is basically a wear phenomena, and as it is said, it is a surface or a near surface phenomena because it comes under the relative motion, basically the rubbing action. And this is a very serious industrial problem. The reason behind is in the industries, we have all the machines, we have all the moving parts, and these moving parts are always in contact with some other part where this rubbing action is taking place. And due to this wear and tear, there is a big financial loss because there has to be a replacement of the part, the part replacement. Secondly, the replacement of part can be done directly. It has to be, we have to stop the production. It has to be taken under maintenance. Then we have to change the parts. Then we have to again start it. The replacement part has to be as equivalent to as the original part. So there are many things associated with it, and that's why the industries, what they want is they can have as good material as possible so that the wear can be taken down as much as possible. And secondly, there is not for every single component, we don't have any measure by which we can know whether the wear has been very much prominent, has been taken place or not, because and due to unknowingly of this phenomena, what happens is like the machines gets under stress, और एक part wear out हुआ है तो उसके जगह पे it's affecting the other component, other material, other motor basically, जिसके कारण the loss starts increasing. So again, it is considered to be a very serious issue, industrial problem, and people are looking into it more and more innovative ways to resolve these issues, which we will discuss like abhi kaun se kar rahe hue hain. So the wear resistance refers to a material ability to resist material loss by some mechanical action. So जो अपन ने बोला कि wear is defined as a loss of material, so wear resistance is basically opposite to that. It will avoid the loss by the mechanical action. So but there is a very important parameter that has to be understood. A material, a wear resistant material does not necessarily require to be hard. ये काफी लोगों में confusion हो जाता है कि ये wear resist material है तो वो hard होगा, तो it's not required to be hard, and it is not necessarily required to be tough. For example, you can take the tire example. So tire are made with the material, उसमें basically इस तरह से उसको develop करा हुआ है कि उसमें wear resistant properties आ सके, because of which you are driving on the road for kilometers, 25,000 kilometers, 50,000 kilometers without changing the tire. The reason behind is इसका material उसमें बनी हुई है, but it is not hard and it is not tough. So you don't mix the wear resistant material with hard and the tough. So this is what the first slide I want to introduce in this part. कि एक बहुत common misconception है among the people, and that's we have to change it. So the wear resistance of a component can be improved by providing surface treatment by various surface engineering methods. So हर एक मटेरियल की अपनी एक प्रॉपर्टी होती है. They cannot be necessarily wear resistant to it, but we need certain flexibility, we need certain requirement जिसके कारण अपन को वो required है कि ठीक है नहीं मुझे यही मटेरियल यूज करना पड़ेगा. Now what we can do to improve the wear resistance of the material by using the same material, that's what is the surface treatment method by surface engineering method का मतलब है. So taking on the surface treatment, there are basically three processes. The first process is कि जो भी parent material है, we call it as a substrate, उसी के ऊपर एक coating लगा दो जो higher wear resistant material है. So because this is a wear resistant, it has a certain special property. It is a costly material, right? So you cannot directly use entire material as a wear resistant material. So what people do is take the basic material जहां पे wear out होना चालू होता है और where there is a wear prone zone, जहां पे basically maximum wear out हो सकता है, उस surface पे एक coating लगा दो उस material की जो highly wear resistive है. So basically the first point, as it says, processes which apply a new material, a coating to the surface that is lead to the formation of a different space with a distinct boundary between itself and the substrate. So not to get confused with the too many jargons over here, but basically एक अपना जो substrate है या तो basic parent material है, उसके ऊपर एक और layer of coating मैंने लगा दी, जिसकी property where resist वाली है. That's what the first process is meant about. Second process है that modify the existing surface by inducing a change in composition of the surface engineered layer. So this is almost I would not say the similar to the first one, but it's also एक उसकी ऊपर की chemical composition एक तरह से change कर दिया या ऊपर का एक जो composition है उसको अपन ने modify कर दिया. The first point says it's totally applying a different layer to the basic surface, and the second point is changing the modification within the parent material by introducing some new elements so that the composition is changed. It's not a different layer of a different material, but keeping the basic material same, just changing the compositions slightly so that it can attain this thing. We'll come to this point again about both the 2 points. And the third process is basically modifying the existing surface without a change of composition, that is a transformation hardening. तो किसी में लिमिटेशन में नहीं लगा सकता, मैं ये भी नहीं कर सकता और मैं उसका कंपोजिशन भी चेंज नहीं कर सकता. So there is a certain process that is taken place with taking the existing surface itself कि ठीक है उसमें जितना बेस्ट हो सकता है उसमें अपन अचीव करके देख सकते हैं. It's just a bit trivial. इसको just explain करने के लिए just a kind of एक illustration is changing suppose एक कोई आदमी है और उसी को अपन को चेंज करके दूसरे फॉर्म में उसको बनाना है. So what are the 3 processes? First कि उसको किसी और के जैसा देखना है तो जो अपन जेम्स बॉन्ड मूवी में देखते हैं कि उसको मास्क पहना दिया, right? So that's the first process. So applying a new layer on the existing layer. So you have put a mask on it. Second, what it is, it's a surgery key. I'm sorry, should I interrupt?
No, sir, continue.
Okay. The second process is a surgery करी. उस आदमी की surgery करके अपन ने उसका हुलिया change कर दिया. So that was the second process. This is the keeping everything same, बस उसका surface अपन ने change किया. First process mask लगा दिया. And third process is using a duplicate कि उसमें जितना best possible चीज है उसी को use करके अपन ने कर दिया. अगर आपने fan movie देखी हो for the Shah Rukh Khan, so that's what I can relate it over here कि he replaced original Shah Rukh Khan in that movie with certain modification in his characteristics so that he can be looked as the same person as a Shah Rukh Khan. So this is to give you a very कैसे बोलेंगे एकदम ही लोकल लैंग्वेज में बोल के बोला था तो कि इसके उसमें अपन changing a person can be taken as an example for the surface treatment what we are talking it about here. So going to the next slide is right now in this presentation basically we will be more or less talking about first and second. मैं आपको बताऊंगा कहां पर अपना surface coating हो रहा है और कहां पर अपन इसको change in composition कर रहे हैं. But surface coating is our basic talk of this thing. तो maximum part मेरा उधर cover होगा. Second मैंने ये इसलिए बताया हुआ है because the surface in जो composition में change कर रहे हैं it's also as I mentioned it's a very thin line to differentiate between a surface coating and the changing the composition because उसमें भी एक बाउंड्री एस्टैब्लिश होती है इसमें भी एक बाउंड्री एस्टैब्लिश होती है दोनों में वो चीजें रहती है तो इसलिए मैंने दोनों पार्ट ही इस प्रेजेंटेशन में कवर कर लिए हैं. So to start about with the surface coating there are some basic requirements. So surface coating you can take it as a bodyguard का अपने पास रखने के लिए अपने बेसिकली 3 इन्होंने एक रिक्वायरमेंट्स बता रखा है कि जो भी surface coating सिलेक्ट करो the surface coating must be able to resist interaction with other parts or with process media. तो जो main purpose है it should not dilute its own purpose. So basically उसका suppose एक certain media में उसको wear को resist करने का purpose है. So it should not happen कि उस media में ये जो अपन ने coating वाला material क्या है वो mix up हो जाए. For example bodyguard जो अपन ने रखा हुआ है so it should not happen कि अगर मेरा अरे ये तो मेरे society का ही आदमी आ रहा है जिससे मुझे जिससे उसको प्रोटेक्ट करना है तो वो उसी के साथ मिलके भैया जिसको प्रोटेक्ट करना है उसी को उड़ा दिया. सो बेसिकली इट्स शुड नॉट इंटरेक्ट विद द मटेरियल वेयर इन व्हिच इट हैज टू परफॉर्म कि उनके बीच में उसका इंटरेक्शन नहीं होना चाहिए. Secondly, the substrate material, the parent material should have the strength to absorb that coating material, कि उसको वो support कर सके. Otherwise, if suppose उसको जो अपन coating कर रहे हैं, it's taken at a high temperature, but the parent material is such that कि वो high temperature पे खुद melt हो जाएगा, तो I cannot apply that coating which cannot resist the high temperature over here on the parent material. तो it has to be properly studied कि जिस पे अपन मटेरियल कोटिंग अप्लाई कर रहे हैं वो मटेरियल की भी स्ट्रेंथ उतनी है कि वो उस कोटिंग करते समय उसको विथस्टैंड कर सके. एंड थर्ड, the coating must be sufficiently strongly bonded to the substrate so that the surface stresses do not cause it debond or spall. मतलब कि आपका जो कोटिंग हो रहा है एक पेरेंट मटेरियल पे, वो कोटिंग उस पे इतनी अच्छी तरह से उस पे एडेसिव होना चाहिए कि जब अंडर परफॉर्मेंस, अंडर वर्कलोड, वो उससे अलग नहीं हो जाए. दोनों चीजें अगर सेपरेट हो गई तो कोटिंग का पेरेंट मटेरियल पे कोट करने का कोई सेंस नहीं निकलेगा. So it should be sufficiently strongly bonded. So these three are the major requirement before you select any surface coating for any component. So there are basically 7 different processes. Even मुझे भी इतना नहीं पहले पता था, but while working for this presentation, I came to know that there are 7 different surface coating methods which we can use. And in our company, basically in Mangalam Stilcast, we are using couple of this method, which will go on when we come into the presentation. But to give you brief about कि कौन-कौन से method से वो हो सकती हैं, तो I will just explain one by one. First is the chemical vapor deposition method. So this is basically a deposition of a solid coating on a heated surface resulting from chemical reaction at the surface involving the surround vapor or gases. Basically what happens in this, there is a chamber, there is a parent material, the parent material is heated up, and then there is a जो अपना interest material है, the one, the surface that has to be coated, it comes under certain form. वो form में उसको इस high temperature पे expose करते हैं, and there is some reaction is taking place with the help of the reactant gases. So when this two thing combines, the coating material and the gas, when it combines, there is the elimination of the waste gas, and the metal which is required to be deposited will start settling on the parent material. So in this example, just use the pen. In this example, this is the reaction chamber. So this is the material of our interest. M is suppose कोई भी एक ऐसा element है that we want to get it deposited on the parent material. So we take this as a composition जो जिस readily available form में आता है. We take this composition, we react it. For example, over here we have reacted with hydrogen. Hydrogen के साथ उसको react किया. Now this material is present in the layer. It's not sticking to the surface. But once it comes under to with the reaction with the hydrogen, there is a formation of 2HCl, again in the form of gases, which gets escape out. And this metal is basically getting deposited over here. वो अपने आप उसके weight से settle होके उस पे parent material पे आ जाता है. Again, इसमें parent material को काफी high temperature पे heat करना पड़ता है, because there is a reaction taking place which is taking place under high temperature this thing. So it has to be the surface coating has to be selected based on this thing कि वो इधर इस element के साथ react भी करे, इधर deposit भी, और ये high temperature पे react करे. It should not directly react with under low temperature or an ambient temperature. Otherwise वो हो सकता है कि कहीं और भी उसके साथ reaction under production purpose में react कर जाए और वो अपना lose कर दें. So this is the chemical vapor deposition. Similarly, there is a physical vapor deposition. In this case, what happens is there is a source. ये अपना source है जो अपना source of interest है जिसको अपन को deposit करना है. तो इसको पहले vaporize करते हैं. With vaporization, and there is a gas inlet. This is a vacuum chamber. There is a power supply for the evaporation sources. So इसको एक spurting phenomena बोलेंगे या इसको evaporate करेंगे. जैसे वो evaporate करेंगे वो particles और फिर यहाँ पर अपना parent matter है जहाँ पर अपन को उसको deposit करना है. तो ये gas और उसके साथ जो होके इस पे ये start होता है deposit हो जाना. इधर वो deposit हो जाता है. तो ये atom by atom. So deposition of coating on an atom by atom basis from the vapor phase, the production of vapor flux being by evaporation or spurting. So एक ये कंडेंस फॉर्म में रहता है, उसको वेपर फॉर्म में कन्वर्ट करते हैं और फिर ये वापस यहाँ पर आके कंडेंस फॉर्म में हो जाता है. सो दिस इज नोन एज फिजिकल वेपर डिपोजिशन. इट इज अगेन एटम बाय एटम, तो इसमें कोटिंग काफी यूनिफॉर्म होती है. इनफैक्ट इसका जो एक है, मेरा एक आगे एग्जांपल है जो जिस चीज के लिए यही प्रोसेस को यूज करा जाता है, इसको शॉर्ट में पीवीडी प्रोसेस बोलते हैं. एंड दिस इज वेरी यूजफुल इन द डिपोजिशन. Then there is the electrolyte splitting. ये आपको काफी लोगों को मालूम ही होगा. इसमें basically it's a uniform coating of a metallic layer on the surface of fibers through chemical reduction of metal ion in an aqueous solution. So basically there is an aqueous solution जिसके अंदर अपन ये अपना component, desired component add कर देते हैं. Then there is a precipitation due to the reaction within the in the aqueous solution, and this is how the metal get deposited over here. And this is a normal phenomena which see in our day-to-day life also with many other मतलब knowingly unknowingly ये phenomena अपन देखते रहते हैं. And fourth one is the electroplating, again very common method. Anode cathode इसमें रहता है, which pass the current and the ion starts shifting, metal ion starts shifting and will deposit it to a particular this thing. So electrolyte splitting and electroplating are the very trivial method to say. एंड ऑब्वियसली इसका यूसेज वहां पर ये हो सकता है जहां पर अपनी रिक्वायरमेंट भी ऐसी है कि हाँ ठीक है इतने से करने से काम चल जाएगा. बट नॉर्मली एटलीस्ट जहां तक मेरे उसमें आया हुआ है, आई हैव नॉट सीन यूज्ड फॉर द वेयर एप्लीकेशन, वेयर रेजिस्ट एप्लीकेशन, बट it has been used. See, this is a very this thermal spraying method we are doing in our company. In this, the coatings are formed by successive impact of a stream of spray droplets in a fully molten or partially melted states and solidification. What it does mean is, यहाँ पर एक मेरा thermal source है, ये जो देख रहे हैं, ये एक thermal source है जो basically flame produce करेगा. इधर से मेरा powder inject होगा, material यहाँ से feed हुआ. When this material comes in contact with the high speed thermal gun, it will start spraying out this molten metals. So this powder may get melted or may be partially melted. जब ये molten metal फिर ये जो अपना parent material है इसके साथ जब टकराता है, it will start sticking to it और यहाँ पर ये solidify हो जाएगा completely. So this is the layer where it will get solidified, and because ये start solidifying तो इसकी एक अपनी एक layer बन जाती है. So this is the gun basically. यहाँ से बेसिकली फ्लेम का ये DA का है, एसिटिलीन गैस है, इधर ऑक्सीजन गैस है, इट विल कम थ्रू, और यहाँ पर ये एक अरेंजमेंट दे रखा है जिससे पाउडर फीड होता है. सो व्हाट हैपेंस, पाउडर एंड द फ्लेम दे रिएक्ट, तो इधर ही उसका रिएक्शन हो जाता है और वो मॉल्टन स्टेट पे कंप्लीट हो जाता है. ये मेरा पेरेंट मटेरियल है, यहाँ पर इट विल स्टार्ट स्प्रेइंग एट अ वेरी हाई स्पीड, और ये जहाँ के मॉल्टन वहां पे जाके टकरा के उधर ही सॉलिडिफाई हो जाएगा, बिकॉज दिस मेटल इज नॉट हॉट. So this will start solidifying over here और एक पूरी की पूरी layer इसके ऊपर deposit हो जाती है. In this case there is a wastage, use wastage. As you can see the spluttering पूरा उधर हो रहा है, इधर सब जगह फैल जाता है. So there is a wastage, but it's a very fast and very effective for thin layer deposit. It is very effective method, and it is being used widely, very widely. Next is welding surface treatment. So in this method it is same as this one what we discuss about के high speed पे अपना जो desired metal है, जो wear resist material है, वो इसके अंदर कोट कर देते हैं. ये इसके अंदर सेम है, but instead of using a gun with the flame, इसमें flame अलग से यूज करते हैं और एक इलेक्ट्रोड फॉर्म में ये मटेरियल आता है जो जिसको अपन मेल्ट करके उसके ऊपर डिपॉजिट करते हैं लेयर बाय लेयर. सो इट एक्ट्स एज अ सेकंड लेयर, इट इज फ्यूज्ड विद द पेरेंट लेयर, and it is deposited slowly and gradually with the help of this electrodes. So this electrode is basically wear resist material. So it's as I define, is the application of hard wear resist material to the surface by a component of welding. So it's almost like a welding, or you can call it as a brazing, जिसमें फ्लेम अलग से यूज करेंगे, वेयर रेजिस्ट मटेरियल इन द फॉर्म ऑफ इलेक्ट्रोड, रोप, व्हाटएवर फॉर्मेट, उसको सॉलिड के फॉर्म में आएगा, उसको मेल्ट करके उसके ऊपर डिपॉजिट करेंगे, एंड दिस विल फॉर्म अ सेकंड लेयर टू इट. Again, this is being followed in Mangalam. We do it over here, and it is widely used. बहुत ही जगह एप्लीकेशन में यूज होता है. फॉर इंजीनियरिंग पर्पस दिस इज जो हैवी इंडस्ट्रीज हैं जहां पर आपका बेसिकली हैमर्स हो गए, बकेट हैमर्स हो गए, इनफैक्ट अपन जेसीबी में आप देखोगे कि ये एक तरह से एक अलग से लाइन ड्रॉ करी हुई रहती है. इट इज नॉट अ डिजाइन, दिस इज अ हार्ड फेसिंग मटेरियल दैट हैज बीन डिपॉजिटेड ऑन द बकेट ऑफ द जेसीबी सो दैट वेयर वहां पे कम हो सके. So this is what the welding surface treatment is, and widely being followed. And then laser surface treatment, since last decade, this has been a very prominent surface treatment method. Now, laser basically it uses the thermal energy of a laser beam for modification, alloying, and cladding surface of substrate material. So, as again over here पे बता रखा है, laser everyone knows about it, how intense it is. So this basically a material is coming over here. Here is my cladding material of interest. That's a wear resist material. ये मेरा मटेरियल आया, इधर इसके साथ मेल्ट हुआ, सेम एज अ थर्मल स्प्रेइंग, बट इसमें लेजर बीम यूज होता है. सो इन दिस द वेस्टेज इज वेरी लेस बिकॉज एक्सट्रीम ऑफ फ्लो ऑफ लेजर बीम है. इन थर्मल स्प्रेइंग दैट्स अ गन, वो पूरी खुद ही फ्लेम क्योंकि पूरा एक्सपैंड हो जाता है, फैल जाता है, तो उसके कारण वो मटेरियल भी ऑल्टर मेटल थोड़ा सा फैल जाता है. बट इन दिस इट्स अ वेरी कॉन्सेंट्रेटेड लेयर, इट्स अ वेरी कॉन्सेंट्रेटेड बीम with which this where resist material comes in contact with, it will start getting melt and it will start getting deposited on the parent layer over here. So this is how the laser process is done. It is again, it is widely being used जहाँ पे अपन को precision हार्ड फेसिंग करनी है या प्रिसीजन कोटिंग करना है, तो वहां पे ये लेजर का काफी इस्तेमाल होता है. प्लस इट गिव्स अ कंसिस्टेंट रिजल्ट. मतलब आपके 10 कंपोनेंट्स है, so if you do it by manually there would be a variation of the consumption of this electrode, but in this case it will be a consistent same amount of deposit. If I ask for 1.5 mm, it will be exactly 1.5 mm of deposit will be done. So again, for precise application, this is a very prominent, and this is an upcoming process and it's widely been accepted in various sector. So we talked about basically 7 surface coating methods जिससे ये हो सकता है, and out of which we are already using this two, thermal spraying method and welding surface treatment. And third one also I have a basic know-how, but we are not using it in-house, but we are getting it outsourced. So now अपन ने सारे मटेरियल्स अपन ने देखे हैं, सॉरी प्रोसेसेस सारे देखे कि कौन कौन से प्रोसेसेस अपन इस मटेरियल को डिपॉजिट करते हैं. बट नाउ व्हिच आर द मटेरियल्स दैट आर बीइंग यूज्ड फॉर डिपॉजिटिंग इट थ्रू दिस मेथड. तो ये कौन कौन से मटेरियल. सो बेसिकली द लेटेस्ट ट्रेंड जो मैं बात कर रहा था, तो दिस ट्रेंड इज बेसिकली दिस मटेरियल्स ओनली व्हिच आर बीइंग यूज्ड currently, जो बहुत ज्यादा पॉपुलर है और ये ज्यादा यूज हुए हैं. So ये सब इवॉल्व हुए हैं. So basically if you see right from the medieval era, the hard facing is being done, the wear resist material coating is being done knowingly or unknowingly. For in that era basically जो अपने एरोज होते हैं उसके ऊपर जो कोटिंग करी रहती है, तो इट्स नॉट अ कोटिंग, बेसिकली उसको कार्बोनाइजिंग प्रोसेस करते हैं. और वो कार्बोनाइजिंग प्रोसेस बेसिकली दे यूज अ बोन, एनिमल बोन, एंड दे फ्लेम इट ऑन अलोंग विद दिस एरो एंड देन दे विल स्टार्ट डिपॉजिटिंग. सो दिस प्रोसेस हैज बीन in existence since very long time, and eventually research after research after research and new addition, they came out with the different components, they came out with the different alloy, and they started playing around with different material, and they found out this material. So basically I'm talking about with the latest trends. It's one of this the prominent is the nickel aluminide. It's a intermetallic alloy of nickel and aluminum, and it has a property similar to both ceramic and metal. So this is a very so ceramic in itself, ceramic tiles जो आती है in itself is used as a wear resistance material. उसको cladding कर देते हैं, but again it has a certain limitation because it's a ceramic, it's a very brittle. So जरा सा भी कहीं भी touch भी हो गया वो टूट जाता है. So this metal, it and then there is the thermal conductivity, and this thing is very poor. Secondly, जब उसको अपन attach करते हैं, so at high temperature जो material है, जो parent material है, it will start coming out. So there are issues with the ceramic, and with this development they came up with a very good alloy which has the property of both ceramic and metal. It is unique in that it has very high thermal conductivity combined with high strength at high temperature. So this is the uniqueness of this thing, because of which it is very popular in application for the coating blades in gas turbines and the jet engines, because वहाँ पर high temperature चाहिए, you need to have high thermal conductivity. And again, the wear out is the major phenomena. अगर उसमें blades में अगर wear out होता है, so you know how it will badly affect in the operation part. So this alloy is very popularly used in that, and this composite material with yeah, there has been many research. I was just reading out the fourth line, which is composite materials with nickel aluminide based alloys as matrix hardened by titanium carbide, zircon dioxide, tungsten carbide, and silicon carbide and graphene are advanced materials. So basically in the matrix of the nickel aluminide itself, they started experimenting it with addition of further hardened material, जिससे अगेन एक ऐसी मैट्रिक्स बनती है कि उसकी हार्डनेस और ज्यादा आने लग जाती है. तो बेसिकली व्हाटएवर ओवर हियर, सो द टाइटेनियम कार्बाइड इज अनदर in itself is a very hard material. Zircon oxide is basically a ceramic material. Tungsten again very hard material. Silicon carbide is another hard material. So basically इसको addition करके matrix को उसको develop करके they are making up a new composite alloy which can be further used in advanced material. As I mentioned in the last line, as it mentioned, in 2005, the most abrasion resistant material was reportedly created by embedding diamonds in a matrix of nickel aluminide. So easy matrix mein they embedded diamond with it. So they made this is known as composite material, because this nickel aluminide in itself is a one alloy, but इसके साथ ऐसी चीज जो merge नहीं हो रही है but mix up हो रही है, that is a composite material. So that this embedded diamonds in the matrix of nickel aluminide. Diamond is it is the hardest material of all with the Mohr scale of 10. So there is nothing to it. तो उसको add करके फिर एक further development हुआ, and they have been developing this. But again, application point of view, cost point of view, where it can be applied, where it can be used, it's very important. And it is not that it's a hard material, so you can use it anywhere you want. It has to be respected with respect to what we read about the 3 initial conditions required. And based on that, they take it forward. Next material is silicon carbide, as I was mentioning earlier. The silicon carbide is again extremely hard. It's a synthetically produced crystalline compound of silicon and carbon. So silicon, as you know, it's basically in itself is a material is very hard, and through a thermal process, basically there is a process with which after reacting with the carbon, it forms the silicon carbide. Uski jo, as it mentioned in the second line over here, it has the hardness rating of 9, which is approaching to that of diamond. Diamond ki 10 hai, so it's just next to it. So it's extremely hard. In addition to the hardness, silicon carbide crystals have fracture characteristics that makes them extremely useful in grinding wheels. So grinding wheels are basically what we say, the metal ko घिसने के लिए, so to smoothen out metals or metal or any other material, basically to smoothen out, they are using these wheels to grind it, to polish it, to this thing. So silicon carbide is popularly used in that because it has a good hardness, and it has a fracture characteristics. Fracture is basically structure is such that ये काटने का भी काम करता है साथ ही साथ में. So that makes it used for the grinding wheel. Its high thermal conductivity together with its high temperature strength, low thermal expansion, and resistant to chemical reaction makes silicon carbide valuable in manufacturing of high temperature application and other refractories. Silicon itself is a refractory material, as you know. So having a high temperature strength, uski thermal expansion is quite low, and it's kind of inert, but it does not react with a lot of material. So it's very much resistant to the chemical reaction. So it's a very popularly used, and you see a day-to-day life, a lot of applications where silicon carbide has been used. Tungsten carbide, this is the material that we are using in Mangalam. Again, this is a very, very, very hard material. The second is the drawback with the silicon carbide is because it consists of silicon. It is very brittle also. It does not have the impact strength. It has a fracture characteristics. So it's good for the grinding application, but it cannot be used for where there is an impact. The tungsten carbide where in this place can take a little bit of impact, like in mining and mineral processing industry. So for mining, again, I was talking about in the JCBs or in this thing where you see the bucket जहाँ से उसको खोदने के लिए use करते हैं, in those area they use the tungsten carbide material. Mining and mineral processing demand wear resistance machine and components because the energies and the masses of interacting bodies are significant. What does it mean? In this process, mineral processing and in the mining application, the component that it comes in contact with the outside material, it comes in very high speed, high impact. So काफी intense environment में ये काम करता है. And for this purpose, इधर aberration भी बहुत ज्यादा होगा, impact भी काफी ज्यादा होगा. So we tend to use the highest wear resistance material where is possible. So इनके examples के लिए it has been shown the tungsten carbide is used extensively in mining, in top hammer rock drill bits, downhole hammers, roller cutters, long wall plow chisels, long wall shear picks, raise boring reamers, and tunnel boring machines. So basically these are all the mining industries applications. And apart from that, there are certain that we are using it at this moment for basically sand mixing. So jahan par apan ko sand in itself, as we saw, it has a more hardness of about 8-9. So it's a very hard material and it's a very abrasive material. So applying the tungsten carbide to the component, what it does, it will come in contact with the sand, this abrasive material, and it will start protecting the main component from coming in contact with the sand and taking all the abrasion by itself. And it's being a very abrasive material in itself, what it will do, it will protect, it will fight against the abrasion. So normally if the same blade is used in a raw form, and if you apply the tungsten carbide coating over it, the same component, the life of that can exceed to 5 to 7 times. So that's what this material, this wear resist material used to do. So it's again a very, very popular tungsten carbide coating. It's a low cost comparatively with comparing to the silicon carbide, it's a high cost. Silicon carbide is a lower cost. Tungsten carbide is a bit higher cost, but again, with the other alloys that we discussed, this is a low cost, and the application is also very easy. So it's popularly used. This is the material which we come into this. This is not basically what I would say. It's adding a second layer, completely a composite material kind of thing, but it is adding a certain element only. It's changing the chemical composition that we were discussing about in the previously. So this is the carburizing process. Again, very popularly used in a lot of industries. This is a carburizing process in which the surface carbon concentration of ferrous alloy, normally a low carbon steel, is increased by diffusion from the surrounding environment. It produces hard, highly wear resist surface material, and with excellent capacity for contact load, good bending fatigue strength, and good resisting to seizures. So basically, carburizing, as you can see from the word itself, it's the low carbon material. So there are certain steels we have to produce because to have a good ductility and all those things, we have to produce it in a low carbon concentration. But to achieve the surface hardening, we need a higher carbon concentration. So this is the process that we use for increasing the carbon layer on the surface, and that way giving a better wear resistance. It's not as good as surface coating by the composite material or by the different altogether material, but it serves the purpose at low cost. Similar to the carburization, it's nitriding. Nitriding is a case hardening process. Again, it's same as above, but in this, the surface nitrogen concentration of ferrous is increased. So similar to the carbon, in this case, we use nitrogen. Again, it gives hard, highly wear resistant surface with fair capacity of same properties as the above. But yeah, in both the process, in fact, the coming process, you need to understand it's mentioned as a shallow case depth. Okay, so this is important, and this is a medium case depth. So basically what does this mean is the depth to which it is deposited and it can act as a wear resistant surface is medium in case of carburizing, and it's a shallow. It's like it's just on the top of the surface in case of nitrogen. So once that surface shallow layer is removed, then again you get the parent material and it will not be wear resistant surface. Similar to this too, there is another one. This is boronizing. Again, it is similar to the nitro carburizing. In this one, it's a boron atom is used, but in this case, the temperature is too high. Okay, I mentioned it in the Kelvin, basically 1000 degrees Celsius, and we have to use it for really long hours. But yeah, again, very good resistance to wear, and it gives a very good property. Plus the flexibility which has the boronizing. It can be used for steel, it can be used for cast iron, it can be used for, I don't think so it's a cement, but this is ceramic materials also, and non-ferrous alloys also. In the previous one that we have saw, it's mainly for the ferrous material. And then this is the case hardening state, in which this will be reflecting to the third type of process which we talked in the initial slides, in which we just modify. We don't do anything new, no new addition to the parent material, but we just modify the structure of the material so that it goes up to wear. So, but we can do it to an extent that it can permit. So basically, in this case, enhanced wear resistance of steel, case hardening based on martensitic transformation is performed. So martensitic hardening is one of the most common method of hardening, which is primarily used for steel. So the microstructure in the steels, it's changed to a martensitic structure. Martensitic structure, microstructure is basically gives a better hardness, better wear resistance. So this is case hardened steel. Again, very low cost, very effective, but not as good as the previous process that we have seen. And this one is the final one. It's a titanium carbon and titanium nitride hardening. So titanium in itself, it's a very extremely hard material, and a titanium nitride, again, nitrogen that we saw, it's a coating of the nitrogen itself also is very hard. So titanium nitride, when in combined together, it forms a ceramic kind of material and a very hard. And this coating is done through physical vapor deposition. The PVD that we studied, the second process that we studied. So through this process, it is done, and it is basically, it is a costly process. So it is basically used for the tool increasing. So basically the raw tool की जो hardness होगी और raw tool की जो property होगी, उसी के ऊपर vapor deposition करके, this is a titanium nitride we use to deposit on this thing. And that way because of this highly ceramic material, the wear resist also increased, the cutting application also increased, because it has what we say is the cutting tendency of this material is very high. So it is majorly used in the spool, in the stool. And the wicker hardness for this is mentioned as about 2100, because it's a very hard material. 1800 to 2100, because it's like you cannot measure in HRC, you cannot measure it with the BHN tool. So it's a very hard. And again, it's just we do the coating of it because it's a very costly process, and it looks like a metallic gold color. So when you see a certain tool and if it's this color, that might be a possibility it has been coated with the titanium nitride. So these were the basic materials, these basic trends that are ongoing trends, which is popularly widely being used as a wear resist material. And we over here are playing a lot with the tungsten carbide. Then there is a chromium carbide also, but again, it does not have that kind of wear resistance as the tungsten carbide has. So it's a very popularly used for this application. And recently, when I was searching for this thing, I can encounter with the certain development by the Sandia National Laboratory that is located in USA. Apparently, they developed a platinum gold alloy. Basically, this is a very popular alloy as such. It's already been made, but they modified a certain characteristics, again, the matrix of it in such a way that it's 100 times more durable than the high strength steel. It's making it as a first alloy or a combination of metal in the same class as diamond and sapphire. So these are the nature's most wear resist material, and they have achieved this properties of the diamond and sapphire with the platinum gold alloy. Obviously, they have not mentioned too much details about this thing, and I think they are still under the process of how to make it as for the coating purpose. But if they have given the example, like just in case if you have a car with the metal tires, then those tires, if you do the coating of platinum gold alloy, which has been developed by them, so it can roam around. It's basically the metal tires, it will not drive, but you will be skidding. So you can skid around Earth equator 500 times before the wearing out of tread. So you know the tires with treads hote hain. So before this will start wear out, you will already be covering like 500 times of this thing. So and if it gets successful, then they have estimated that with this coating they can save the electronic industries for more than about $100 million a year in materials alone. And it can be used across many industries for cost-effective and long-lasting and dependable solution. So right now, they mention like aerospace system and wind turbines to microelectronics for cell phone and radar. So basically, in your cell phones and radar system also, you will have this material. This will be acting as a wear resist material. So so many things are coming out. This thing is again, as I mentioned, achieving this is something very much remarkable achievement, because you are going to the nature's most wear resist material equivalent to that thing. So yeah, that's the latest development which I have come across. And then this is my final slide. So basically, wear resistant coating are key to efficiency in production and saving direct and indirect losses, because in industries we are all using, as I mentioned in the earlier, it's all the moving components that are being used, and this component come across with various other materials, and this materials, when it come in contact with other materials, it will start to wear out. It directly affects the production, because you have to change the part and it cannot work it with the full efficiency. And then there is an indirect losses because it's connected to some other part, and now because part is not performing efficiently, the other part is getting damaged due to it, which वो वाला काम कर रहा है जो उसको नहीं करना था. Because of that, it get damaged, and so there is, I mentioned, it's like a direct and there are indirect losses due to it. So it is a very much hot topic of interest and research for industries and academics. So if you are at all, any one of you is thinking about what topic to choose, so this is one of the very interesting topics. And see, I think it's a evergreen topic, because you can just start explore again and again and again, because आज की डेट में मेरे पास अगर उसकी लाइफ 10 days है, so I will like to research and try to increase the life to 15 days. Once you achieve the 15 days, then there will be someone person who will, no, not 15, I want to achieve it life to 20 days. So this thing is a never ending process, and there would be more and more demand. It's basically our human nature. So, and because it's affecting a lot in the industries, and it's industry production, and it's directly related to the economics of the industries. So I think it's going to be a very good topic to take it forward. And yeah, let me know in case of any other doubts, queries, or you, and I can.
Hello, sir. Am I audible? Hello.
Yes, sir. You're audible.
Yes, sir. Mr. Sumit Das, sir, is one of the professor at our university. I asked one question to you. What are the various coating materials used for metal matrix composites in industries?
Sir, I answered, like a couple of slides were there. Metal matrix, basically, if you ask about the component, there is a nickel, carbon, boron, and tungsten, chromium. So these are the major components, elements, sorry. These are the major elements that are used for forming this matrix. Now, what they do is play around with this matrix with the different composition, so that the desired hardness can be achieved. So the material that we are using of the tungsten carbide, it has a matrix of nickel, boron, and carbon. And they have made it, basically this material has a patent on it. So basically the hardness through this, we are achieving about 3000 Vickers. Yeah, these are, if I can answer it in a short, so this is the major elements that are used for the metal matrix components.
Sir, other question asked by same faculty, Sumitra sir, is any recent materials that are being used for coating in recent times?
In
recent times, coating materials.
Coating materials. So basically, as I mentioned, these are the material which I have mentioned over here in the presentation. It's all from the recent times that are already going on. So people are using it as in today as a surface coating material through various processes. So like titanium nitride, which I mentioned, through PVD process, they are using it for coating it on the tools. So these are all, the presentation covers this all, the current materials only.
Okay, sir. One more question from Jalpa madam side. In case of hardening, is a type of coating or although different process?
I'm sorry, can you repeat again? In case of
in case hardening is a type of coating or although different process?
Basically, case hardening is not coating. Case hardening is, as I mentioned earlier, so basically there are three processes through which you can get the wear resistant properties. So the first process is coating. You apply a second material, altogether a different material on the parent material. Second process is changing the composition of the parent material, like adding carbon, nitrogen, boron to it. And third process is not changing any chemical composition, but changing the microstructures to say, or the properties through a certain process, so that the parent material remain the same. There is no change in chemical composition, but we have changed the microstructure to achieve the desired properties. So the case hardening comes under third process. So in this, it's not a coating. It's basically the component is it's treated with a certain phenomena. For example, just you can say the flame hardening is a kind of a case hardening. You heat that temperature to heat that component to a very high temperature, then you immerse in a water, and through which there is a Marten's-type structure is formation take place on the surface of that component, and that acts as a wear material. So the case hardening is similar to this one.
Okay. Nirav sir, you have any question?
Yeah, good afternoon, Pravit sir. How are you?
Good, sir. I'm doing good, sir. Thank you. How about you?
This is Nirav Gandhi. Yeah.
Yes,
so I wanted to ask you a question. Which the most prominent this surface coating technique? You discuss, all these 7 coatings, but nowadays, in this industry, I mean, which coatings are more prominent or the fastest one?
So the fastest one, see, actually depends a lot on the application to application. But majorly, if I say about the heavy industries, they go for either thermal spray method or welding treatment or laser coating. So this is the combination. So basically all the three, these processes are similar. They are using same method, like taking the coating material to a very high temperature so that it gets melted, and then depositing it or solidifying it on the parent material in which the coating is required. So all these three processes are of the similar nature, but a different method. So like in the thermal spraying, we are using a gun at high temperature. The flame comes out, and along with the flames, this get deposited on the parent material. In the second process, we use electrode. We don't use gun, we use electrode. We just melt it and deposit it on the parent material. In the laser beam, we use the laser process, the beam, the intense thermal energy of the laser beam to melt the coating material and deposit on the surface layer. So these three are the most common one, and they are being widely used. Now, depending on the cost economics and the surface tolerance that they have, they need it, they can use either of these three processes. And the PVD is basically being used for the tool. So basically, yeah, it depends on very much application, but I will say for the heavy industry, these are the three major processes that are being used.
Thank you, sir. One more question.
Yeah.
Do we need to measure the thickness of this coating? I mean,
Yes, sir. Yes, sir. It's very important to have the thickness coating available with us because, again, in the industrial or engineering application, there is a tolerance thing plays into a picture. Like if certain part is touching with some other part, so there is a certain tolerance is given. Okay, it should not be going too high, it should not be too low, so that there is a gap between these two. So what they do is, suppose there is a coating required of 1 mm. So they will make the component 1 mm smaller, and then the coating is done with 1 mm only. It cannot exceed to 1.5 and it cannot be short by 0.5. So the thickness of the coating is being measured.
thank you, sir. Yeah, it is over to you, it is, sir.
Yes, sir. One more question from Sumit sir side.
Yeah.
Sir is asked, is platinum gold alloy coating, it started to being used in industries or only it is in a research stage?
Yeah, I don't actually, I came across recently only when I was reading it's about, I guess, 2018 or 20 only they developed this material. Then I searched for it, whether it is being used, but I don't think so. As of now, it's being used. It's right now what I studied is they are still trying to formulate a method so that making alloy is a different part. Now depositing it on a certain material and retain its property, it's the second part, which is the very tough part. So the composition they have made it, but again the deposition method, I don't think so I have come across anywhere that they can say, okay, now it is finalized kind of thing. So maybe I'm wrong, but I have not come across, so I'm not aware about it. It's being used in industry.
Okay, sir. Thank you. Great, sir. Thank you. Finally, we come to end this session, and I would like to thank Mr. Praveen Kumawat, sir, for sharing the knowledge on latest trends in wear resistance coating in industry and give his valuable time. Also, I would like to thank Professor Imran Molvi, Head of Department, Mechanical Department, Principal Sir, Dean Sir, Provost Sir, and President Sir of Palo University for providing me the opportunity to arrange such webinar. Thank you. Thank you for you all participating in today's webinar. We hope to see you again next time. Thank you, sir.